The expression 5 star, 4 star, 3 star, 2 star, 1 is chosen from plus, minus and into each at most 2 times. In the expression 5 star, 4 star, 3 star, 2 star, 1, star is chosen from plus, minus into each at most 2 times. What is the smallest non-negative value of the expression? And so it's like 5 dash 4 dash 3 dash 2 dash 1. This cannot be into 5 into 4 will take it to 20. It's too high. It will become. I feel like we need to have minus coming at least once or twice. So let's see. We put a minus here, minus here, minus here, and then put into. Something like that. We're just trying this out. 5 minus 4 minus 3 into 2. 3 into 2 is 6. 5 minus 4 minus 6 is 5 minus 10. Minus 10 plus 1 is minus 9. One of the smallest non-negative value. And so I like the 3 into part. So the minus of 3 into something we can do there. It's chosen at most 2 times. Each at most 2 times. So this didn't work because it goes to negative. But now we know that we have to use plus and minus in some form. Answer choice is 0, 1, 2, 3. So we should look to generate one of these numbers, right? So 0 is obviously the most powerful that we will want to see. Let's see. 5 plus 4 minus 6 minus 1. So let's do this. 5 plus 4 minus 3 into 2 minus 1. 5 plus 4 is 9. 9 minus 6 is 3. 3 minus 1 is 2. So we've got 2. So this is out. Maybe we can generate 1. Right? So let's see if we can do that. 5 plus 4 9 minus 3 into 2 into 1 is 6. Doesn't work. Interesting question. We'll have to figure out a way of generating smaller numbers. Right? So let's say 5 minus 4 minus 3 plus 2 into 1. 5 minus 4 minus 3 is 5 minus 7 plus 2 is 0. 0 works. We can confidently mark 0. Initially I thought 5 minus 4 minus 3 plus 2 minus 1 or plus 2 plus 1. So that will take us to 1, but plus 2 into 1 will take us to 0. Brilliant. Once you've got 0, we can confidently mark 0. 0 works. 0 is the smallest. Non-negative value is 0. A certain number of men can complete a piece of work in 6k days, where k is a natural number. By what percentage should the number of men be increased so that the work can be completed in 5k days? Right? So 6k and 5k. I'm going to say, hey, 6k days, the number of men working, let's say is 5n. I'm not taking n, I'm saying 5n. Why? Because if there are 5k days, we'll need 6n. Total amount of work is 6k into 5n, 30kn, 5k into 6n. 6k days, 5n people working, 5k days, 6n people working, they'll achieve the same objective. 5 people working for 3 days or 3 people working for 5 days is the same output. So the number of men goes from 5n to 6n. By what percentage should the number of men be increased? 20%. 5n to 6n, 5 to 6, increase of 1 on a starting point of 5, 1 by 5, 20% done. X, Y and Z can complete a piece of work individually in 6 hours, 8 hours and 8 hours respectively. However, only one person at a time can work in each hour and nobody can work 2 consecutive hours. All are engaged to finish the work. What is the minimum amount of time they'll take to finish the work? Right? So, in 1 hour, X can do 1/6 of the task, Y can do 1/8, Z can do 1/8. Right? LCM of 6 and 8 is 24. Suppose we define task as 24 units of work. Then in 1 hour, X can do 4 units, Y can do 3, Z can do 3. We want to do this as quickly as possible. That means we should have X working a lot, as much as possible, but not consecutive hours. So we'll have X, next hour being Y, then X, then Z, X, Y, X, Z, something like this. We can use Y and Z interchangeably, same efficiency they have. X has to be used as much as possible. So start with X, every other hour is x. We say 4 plus 3 plus 4 plus 3 plus 4 plus 3 plus 4 plus 3 and so on. Wherever it crosses 24, that's our answer. 24 units is our total time. Right? It doesn't cross 24, but it reaches 24, not cross 24. 4 plus 3 is 7, 7 plus 7 is 14, 21. At the end of this, it becomes 25. 4 plus 3 plus 4 plus 3 plus 4 plus 3 plus 4 is 25. So 7 hours will go beyond completion. In 6 hours, we have done 21 units. We have only 24 units of work. So in the 7th hour, we have only 3 more units of work remaining. In an hour, we can do 4 because 7th hour x is working. So we need to work 3/4 of an hour in the 7th hour. So xy, xz will finish 21 units. The 7th hour x will work for 3/4 of an hour to take us to 24. 3/4 of an hour is 45 minutes. 6 hours and 45 minutes is our answer. How many consecutive zeros are there at the end of the integer uptime? 1 square plus 2 power 4 plus 3 power 6 plus 4 power 8 and all the way till 25 power 50. Interesting question. How do you get a 0? You get a 0 when you have a multiple of 10. Any multiple of 10 will end in 1 0. Multiple of 100 will end in 2 zeros. Multiple of 1000 will end in 3 zeros and so on. So this question is how many 10s are there? This 10 is 2 into 5. So, we will have to think about how many powers of 2 are there, how many powers of 5 are there. You combine these two, you will get 10s. Right? There are 10 2s and 10 5s, we will get 10 power 10. There are 20 10 2s and 20 5s, we will get 10 power 20. If you have 2 power 11 and 5 power 6, we will be able to get 10 power 6. You have 2 power 7 and 5 power 22, we will be able to get 10 power 7. Okay? 2 and 5 combined to give us a 10. Whichever is lesser, that many 10s we can form. Okay. When you do 2 power 4, 4 power 8, 8, 2, 4, 6, 8, 10, 12, all of them will contribute 2s to us. 4 gives us 2 2s, 8 gives us 3 2s. Right? Obviously, there are lots more 2s than 5s. So, effectively, we need to calculate only how many 5s are there in this number. Right? So, this question boils down to what is the highest power of 5 that divides this number. Where do 5s come from? They come from multiples of 5. So, effectively, you have to think about 5 power 10, 10 power 20, 15 power 30, 20 power 40, 25 power 50. These numbers contribute to 5s, these numbers contribute to zeros. 5 power 10 will give us 10 5s. 10 power 20 is 5 to 2 power 20, this will give us 20 5s. This will give us 30 5s, this will give us 40 5s. 25 power 50 will not give us just 55, it will give us 100 5s. 25 itself is 5 square. 5 square whole power 50, 5 power 100. This number gives us 5 power 10, 5 power 20, 5 power 30, 5 power 40, 5 power 50. Product of all of this will result in 5 power 10 plus 20 plus 30 plus 40 is 100, 100 plus 100, 200. Lovely. On January 1st, 2023, a person saved 1 rupee. On January 2nd, he saved 2 rupees more. On 1st, it is 1 rupee. On 2nd, it is 3 rupees. 3rd, 2 more than that, 5 rupees. 4th, 7 rupees, and so on. Okay. At the end of which date was his total savings a perfect square as well as a perfect cube? So each day he saves consecutive odd numbers 1, 3, 5, 7. Sum of n odd numbers is n square. Right? 1 is 1 square, 1 plus 3 is 2 square, 1 plus 3 plus 5 is 3 square, 1 plus 3 plus 5 plus 7 is 4 square, 1 plus 3 plus 5 plus 7 plus 9 is 5 square, and so on. So every number is a perfect square. Right? Total savings at the end of 2 days, 5 days, 11 days, 14 days, 18 days, it's a perfect square. When will it be a perfect cube also? What is the smallest square? That's also a cube. 8 square is 64, which is 4 cube. So 8 square equals 64, which is 4 cube. 2 cube is not a perfect square, 3 cube is not a perfect square, 4 cube is a perfect square. So the total becomes 64 on the 8th of January, which is when it will be a perfect square and perfect cube. What percentage of water must be mixed with honey so as to gain 20% by selling the mixture at the cost price of honey? And so we have honey, and then to this we add water. We sell at the same cost price of honey, same cost price per liter. Right? So let's say 1 liter of honey we have, we'll sell 1 liter plus some quantity. And when we claim to sell 1 liter of honey, we'll be selling less than 1 liter of honey because we mixed it with water. Okay. Don't think of it in terms of how in 1 liter how much water will be there. Think of it as we can hypothetically say 1 liter of honey we have, we are adding some water and selling it. Whatever water we are adding, that's our profit. Profit is 20%. Honey comes at the same cost. So extra money we are making is from water, or this is 200 ml, 20%. So what percent of water must be mixed with honey so as to gain 20%? 20%. Remember the question said what percentage of this mixture is water? Then that won't be 20%. That will be 200 ml by 1.2 liters into 100. The question is not saying what percentage of the mixture is water. It's saying to honey, what percentage of water should be added? 20% should be. P's salary is 20% lower than Q's salary, which is 20% lower than R's salary. By how much percentage is R's salary more than P's salary? And so P, Q, R. P's salary is 20% lower than Q's salary, which is 20% lower than R's salary. I'm going to start with R. This is 100, this is 80. 20% lower, this is 100, it becomes 80. Multiply by 0.8. 20% lower, remember this is 20% lower than Q. This will be 80 into 80 by 100, which is 64. If R's salary were 100, Q's would be 80, P's would be 64. Okay. Now the question is by what percentage is R's salary more than P's salary? This is 64, that is 100. The delta is 36. Percentage more is 36 by 64 into 100. Divide by 4, 9, 9 by 16 into 100. 9 into 25 by 4. 225 by 4. 200 by 4 is 50. So this is 56, a little more than 56, 56.2. A number is mistakenly divided by 4 instead of multiplying it by 4. Instead of multiplying it by 4, it's divided by 4. And so if we have the number to be 4k, it is written as k, whereas it should have been 16k. Instead of 16k, it is k. It is mistakenly divided by 4 instead of multiplying by 4. It should have been 16k, it turns out to be k. What is the percentage change in the result due to this mistake? What was 16k is now written as k. Percentage change in result, 15k by 16k into 100. 15 by 16 into 100, pretty large number. Right. 1 by 2 is 50%, 1 by 4 is 25%, 1 by 8 is 12.5%, 1 by 16 is 6.25%. This is 100 minus 6.25%, 100% minus 6.25%, which is 93.7. In an examination, 80% of students passed in English, 70% of students passed in Hindi, and 15% failed in both subjects. Right? So, the classic Venn diagram question. English is 80%, Hindi is 70%, failed in both is 15%. What is the percentage of students who failed in only one subject? It's definitely an intersection. This where x, this will be 80 minus x, this will be 70 minus x, or 80 minus x plus 70 minus x equals 85. All in percentage terms. This is 85% totally. This is 85, which means x equals 150 minus 85, which is 65. So this is 65, this is 15, this is 5. 15 plus 15 is 30, 30 plus 70 is 100, it all adds up. So what percentage of students who failed in only one subject? Failed in only one subject. This is passed both. Passed in English, passed in Hindi, and 15% failed in both subjects. 15% failed in both subjects, 65 passed both subjects. Students who failed in only one subject are the ones who passed in only one subject. They failed in one, passed in the other. 15 plus 5, 20%. A can X contains 399 liters of petrol and a can Y contains 532 liters of petrol of diesel. They are to be bottled in bottles of equal size so that the whole of petrol would be and diesel would be separately bottled. Right? The bottle capacity in terms of liters is an integer. How many bottle sizes are possible? And so we have 399, bigger 532. We are putting in some small bottles, some say n liters. How many? What will be the total capacity number of bottles used? It is 399 by n, 532 by n. Now we know n is an integer. There to be the bottle capacity in terms of liters is an integer. The number of bottles should be an integer because they are completely bottled separately. Right? So n should be a factor of 399. N should be a factor of 532. How many different values of n can be there? N can be 1. 399 liters, 532 liters. Right? So we need to factorize 399. We need to factorize 532, and then see where that takes us. 399 is 1 into 130. Sorry, 3 into 133. 133 is a multiple of 7. 3 into 7 into 19. Let's do 532. 532 can be written as 2 into 266, or 2 into 133, 2 into 2 into 7 into 19. This is 3 into 7 into 19, that is 2 into 2 into 7 into 19. The highest common factor between these two is 7 into 19. HCF is 7 into 19, or our number n can be 1, can be 7, can be 19, can be 133. All factors of 133. How many bottle sizes are possible? 4 different bottle sizes are possible. Consider the following statements in respect of the sum x plus y plus z, where x, y and z are distinct prime numbers, each less than 10. And so distinct prime numbers less than 10 are 2, 3, 5, 7. X, y, z are distinct prime numbers, each less than 10. We can write all combinations. Could be 2, 3, 5, 2, 3, 7, 2, 5, 7, 3, 5, 7. S could be 10 or 12 or 14 or 15. Possible values of x are 10, 12, 14, 15. Unit digit of x can be 0. Yes, it can be. Unit digit of s can be 9. No, it cannot be 9. Can be 5. Yes, it can be 5. It can be 2, 3, 5 or 3, 5, 7. So statement 1 and 3, which are the statements given above are correct? 1 and 3 both could be correct. 1 and 3 only. Only 4 combinations, write everything and we're through. A father said to his son, N years back, I was as old as you are now. My present age is 4 times your age N years back. I'm going to think about it like this. Father, son, present or current ages, and N years back. Right. N years back, I was as old as you are now. Okay. My present age is 4 times your age N years back. So, N years back, I'm going to assume son's age was K, then father's present age is 4K. It's 4 times it's given. My present age is 4 times your age N years back. N years back, son's age was K, father's present age is 4K. Right? N years back, father's age would have been 4K minus N, son's present age is K plus N. If the sum of the present ages of the father and the son is 130 years, what is the difference of their ages? So, interesting. So, we need to figure out, we know that this is present age is 4K, this will be 4K minus N. This is K, this will be K plus N. N years back, I was as old as you are now. So, these two are equal. K plus N equals 4K minus N. 2N equals 3K. N is 3 by 2K. This is K. This is 3 by 2K. So, K plus 3 by 2K is 5 by 2K. 4K minus 3 by 2K. 8K. This is 5 by 2K. Nice. Brilliant. The sum of the ages of the father and the son is 130 years. That is 4K plus 5 by 2K is 130. 13K by 2 is 130, or K is 20. So, father's present age is 80, son's present age is 50. N years back, the father was 50, son was 20. What is the difference of their ages? 80 minus 50 or 50 minus 20? 30 years. Consider the following: 1,000 liters is 1 meter cube. I know that 1000 centimeter cube is 1 liter. 1 centimeter cube is 1 milliliter. 1000 centimeter cube is 1 liter. So, this is centimeter cube. So, 1000 into 1000 centimeter cube is 1000 liters. This is 100 centimeter, 100 into 100 into 100 centimeter cube is 1000 liters. Yeah, this is 1 meter cube. 1 meter cube is 1000 liters. Yes, this is correct. 1 metric ton is 1000 kilograms. Definition correct. 1 hectare is 10,000 meters square. 100 meters by 100 meters. Yes, that's also correct. 1, 2 and 3 all are correct. Let x be a 2-digit number and y be another 2-digit number formed by interchanging the digits of x. If x were AB, y would be BA. If x plus y is the greatest 2-digit number is 99. This should be B plus A, this should be A plus B, this is 99. Then what is the number of possible values of x? Sum of the digits should be 9. So, we could have 18, 27, 36, 45, 54, 63, 72, 81. 0 is not possible. So, 9 zeros, 09, they are not possible. 1 to 8, everything can be the starting digit, 8 possibilities. Weight of 6 boys equal to weight of 7 girls equal to weight of 3 men equal to weight of 4 women. Average weight of the women is 63 kilograms. What is the average weight of the boys? Average weight of the women is 63 kilograms. Weight of 4 women equal to 6 boys. 4 into 63 is 6 into something, or average weight of boys. 4 into 63 by 6 2/3. 2 into 21, 42 kilograms. How many times the hour hand and the minute hand coincide in a clock between 10 a.m. and 2 p.m.? Very nice. Put this. This is 12, 3, 6, 9, 10 a.m. This is this time. Okay. And then the minute hand keeps moving, keeps moving, keeps moving. It goes like this, goes like this, goes like this. By the time we go to 11 a.m., it would have overtaken the hour hand. Minute hand between 10 and 11, it will cross completely and come there. Right? So, somewhere it should have caught up. And that somewhere is not 10, 10, 10, 15, 10, 20, 10, 30, 10, 35, 10, 40, 10, 45, not 10, 50, beyond 10, 50, before 10, 55 is where it catches up. So, I'm going to mark that time. Say, hey, nice. 12, 3, 6, 9, 10, 11. So, somewhere beyond 1050, but before 11. Sometime like this, the minute hand catches up with the hour hand. Nice. Then it goes away further. At 11 o'clock, it will be here. And then it goes completely and again catches up. When does it catch up? Beyond 11 o'clock for sure. Not 11:10, 11:15, 11:20, 11:25, not 11:55, beyond 11:55. Because by the time the hour hand would have left, exactly at 12, one will be on top of the other. So, what this is, let me be careful, let me be consistent. Well, 3, 6, 9, exactly at 12, the minute hand will be on top of the hour hand. Nice. Then the minute hand runs away. And then the minute hand goes further. Again, it will catch up. Right? But full one circle of minute hand, it won't catch up. Because hour hand is moving from 12 to 1. Minute hand has gone beyond 12. It's coming all the way back to 12. It won't catch up. 12 to 1, no meeting point. Beyond 1, it will catch up. Beyond 1.5, it will catch up, but not 1.10. Very close to 1.5, 1.6, somewhere there it will catch up. It's our next catch up point. After that, the minute hand will go all the way till 12. That will be 2 p.m. Till then, there's no catching up. It will come back again and catch up. Beyond 2:10, little bit beyond 2:10, maybe 2:11, it will catch up. So, between 10 a.m. and 2 p.m. is one just below 10:55, one exactly at 12, one just above 1.5, 3 times it will catch up. More technically, between one catch up and another, there are 12 by 11 hours. From 12 o'clock, 12 by 11 hours later, it will catch up. From there, 12 by 11 hours later, it will catch up again. 12 by 11, 12 by 11, 12 by 11. So, in one 12-hour cycle, it will catch up 11 times. The calendar for the year 2025 is the same as for, let's do 2025. I'm going to say 26, 27, 28, 29, 30, 31, 32 and so on. 2025 to 26, 1 year, non-leap year, whatever calendar was here, be plus 1. What do I mean by that? if a particular day was a Monday, if Jan 14th were a Monday, then Jan 14th of this year will be a Tuesday. 365 days. 365 is 52 into 7 plus 1. 52 full weeks and 1 day. So the calendar will be shifted by 1 day. 26 to 27, 1 day. 27 to 28, 2 days. Why? 2000, sorry. 25 to 26 is 1 day. 26 to 27 is 1 day. 27 to 28, if you're thinking about it, that's at the February 29th element comes in. You have to worry about February 29th element that comes in 2028. So March 1 onwards will behave differently compared to February 26th or 27th. The new day gets introduced. 2028 is a leap year. Half and half, I'm going to count this as plus 2 and then say for most of the year after March 1 it is plus 2. This plus 1, plus 1, plus 1, plus 2. Right? Cumulatively, if you think about it, 25 to 27 is plus 2, 25 to 28 is plus 4, except 25 to 28, if you think about it, Jan 3rd 2025 to Jan 3rd 2028 will only be plus 3, but March 3rd to March 3rd will be plus 4. But we are not worried about it. Count it as plus 4, plus 2, 1 plus 1, 2 plus 2, 4, 5, 6, 7. 2031 will be exactly 7 days fully. That is a full cycle. Will PQ, R and S be distinct positive integers, PQ be odd and R plus S, R and S be even? Which are the following, consider the following statements, which of them are true? P minus R the whole square into Q into S is even. S is even, so this is be true. Into Q into S, S is an even number, anything into S will be an even number. All of these are positive integers. Q minus S whole square into Q square into S is even, true. Why? I don't have to worry about anything, S is even. Any number into an even number is even. Q plus R whole square into P plus S is odd. This you'll have to check. Q plus R odd plus even, this is odd number, square. P plus S odd plus even, odd. Odd number square is odd, into odd number, odd into odd is odd. This is odd, this is also true. Which of the following statements are correct? 1, 2 and 3, all 3 are correct. What are we using here? Odd plus odd is even, even plus even is even, odd plus even is odd, even plus odd is odd. Even number into anything is even. If product of two numbers is odd, only if, it will happen only if both are odd. And using the tuck funda. What is the angle between the minute hand and hour hand when the clock shows 4:25 hours? Interesting. 12, 3, 6, 9, 4, 5. 4:25 hours. That means our hand is between 4 and 5. Minute hand is on 5. I'm going to draw the minute hand first. Nice. The hour hand will be between 4 and 5, but not halfway there, less than halfway there. Right. So let's draw the hour hand and then we'll go to the exact numbers. Nice. So what is the angle between hour hand and minute hand? Between 4 and 5, that's 30 degrees. Totally 360 degrees. Between 2 points, there's 30 degrees. We know the minute hand is at 5. We know the hour hand has not yet reached the midpoint. Right? That means, very interestingly, this angle is more than 15 degrees. At 4:30, it will be at the midpoint. 4:25, not yet, it has not yet reached the midpoint. So it is behind the midpoint, whereas this is already at 5. If it is exactly midpoint, it will be 15 degrees. Our answer is more than 15, but slightly more than 15. Now we look at the choices. Done, through. Person buys 3 articles P, Q and R for 3,330 degrees. P costs 25% more than R and R costs 20% more than Q. P, R, Q. 25% more than R. So if this were 100, this would be 125. 20% more than Q. The ratio is 5:4. R and Q, if Q were 100, R is 120, 6:5. This is 5:4, this is 6:5. I'm going to say, hey, make this as 12. This is 15:12, 12:10. The ratio of the three prices are 15:12:10. Total is 3330. What is the cost of P? The 15x, 12x, 10x. Add all this up. 27x, sorry, 37x is 3330. I can already sense that this will be a nice multiple. Why? Well, otherwise, these kind of questions, these are all nice integers. 37 into 3 is 111. It's 333. 37 into 9, or x is 90. What is the cost of P? P cost 15x. 90 into 15, 1350. What are the number of fives used in numbering a 260-page book? 260-page book. I'm going to think about 0 to 99, 100 to 199, and then we take our everything else. 0 to 99, where will 5 get printed? 5, 15, 25, 35, 45, 55, 65, 75, 85, 95. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not just this. 50, 51, 52, 53, 54, 57, 58, 59. 5 plus 5, 10. 10 times in the units place, 10 times in the tens place. 0 to 100 or 0 to 99, it gets printed 20 times. Remember a very important point here. There are only 19 numbers which have a 5 in them. Right? Because there are 10 numbers here, 10 numbers here, this number is common. Only 19 numbers have a 5 in them. But 5 gets printed 20 times because 55 has 2 5s in it. The question is saying what is the number of 5s used in numbering? Number of 5s 20. Right? Likewise, 100 to 199, there will be 20. 200 to 299, again there will be 20. But it's a 260-page book. So, out of this 20, beyond 260 they won't come. These 4 won't get counted. From this, 4 will get removed. So, if I have to do 200 to 260, only 16 numbers are there. 20 plus 20 plus 16, 46. What is the rightmost digit preceding the zeros in the value of 30 par 30? 30 par 30 is 3 par 30 into 10 par 30. This will be 30 zeros at the end of 3 par 30. All we need to do is find the last digit of 3 par 30. 3 par 1, last digit is 3. 3 square, 9. 3 cube, 9 into 3, 27. 3 par 4, 7 into 3, 21 or 27 into 3, 81. 3 par 5 is 243, back to 3. So, the powers of 3 end in 3971, 3971, 3971 in sequence, nicely in cycles. So, 3 par 4, 3 par 8, 3 par 12, 3 par 16, all of them will end in 1. So, 3 par 20 will end in 1. 3 par 28 will end in 1. 3 par 29 will be here. 3 par 30 will be here. 3 par 30 ends in 9. 3 par 30 into 10 par 30 will have 9 followed by 30 zeros. So, what is the rightmost digit preceding the zeros? 222 par 333 plus 333 par 222 is divisible by which of the following numbers? First of all, beautiful thing. 222, sum of the digits is 6. 333, sum of the digits is 9. 111, sum of the digits is 3. First thing to do, 111 is 3 into 37. So, it's divisible by which of the following numbers? 222 is a multiple of 37. 333 is a multiple of 37. This will be a multiple of 37. 222 is a multiple of 3. 333 is a multiple of 3. This will be a multiple of 3 also. And so, it's a multiple of 3, it's a multiple of 37. You have to verify 2. 222 par 333 is an even number. 333 par 222 is an odd number. Even number plus odd number is odd. So, this is not a multiple of 2. It definitely a multiple of 3, definitely a multiple of 37, not a multiple of 2. 2 and 37, sorry, oopsie. 3 and 37, but not 2. Three numbers x, y, z are selected from set of first 7 natural numbers such that x is greater than 2y greater than 3z. How many such distinct triplets x, y, z are possible? X is greater than 2y greater than 3z. The first 7 natural numbers. Right? So, x has to be the largest, should be so large that even when we multiply by, even when we think 3 times z, it will still be higher. I am going to start by saying, hey, let me put x as high as possible. I want to think about x, y, z, put x as 7. 3 numbers are selected from the set of first 7 natural numbers such that x greater than 2y greater than 3z. Right? So, it should be greater than 3z, means z can be 1, z can be 2, z cannot even be 3. So, this can be 1 or 2. It is greater than 2y, y can be 3, y can be 2. But they are selected from the set of first 7 natural numbers. So, we could have x, y, z as 7, 3, 2, 7, 3, 1 or 7, 2, 1. 7, 2, 2 is not possible. Y and z cannot be selected from first 7 as to be the same number. 7, 3, 2, twice of y, thrice of z, 7, 3, 1, 7, 2, 1. First thing we notice, z can only be 1 or 2, y can only be 1, 2 or 3, nothing else is possible. Right? The moment I put z as 3, 3z becomes 9. If I put y is 4, 2y becomes 8. X cannot be more than 7. So, x is 7, these are the possibilities. Now, we go to x is 6. X is 6, 2y should be less than 6, y can only be 1. 3z is less than 6, can only be 1. 2yx, y can be 1 and 2, z can only be 1. Or one possibility here is 6, 2, 1. Nothing else is possible. If I put 6 and if this is 6, this has to be only 1. This can only be 1 or 2, 6, 2, 1 is a possibility. So, we have 7, 3, 2, 7, 3, 1, 7, 2, 1, 6, 2, 1. After that, if we put x is 5, right? Z can only be 1, y can be, what can y be? Can y be 2, 5, 2, 1, is that a possibility? 5 is greater than 2 into 2, greater than 3 into 1. So, 5, 2, 1 is a possibility. X cannot be 4 or lower. So, 7, 3, 2, 2y, 3z, that is possible. 7, 3, 1, 7, 2, 1, 6, 2, 1. Of these, this is not, and then 5, 2, 1. Of these is not possible because in this case 2y will be equal to 3z, not possible. So, 7, 3, 1, 7, 2, 1, 6, 2, 1, 5, 2, 1. There are 4 possibilities, 4 triplets are possible. Here we are evaluating x greater than 2y, x greater than 3z separately, and then we keep in mind that 2y should be greater than 3z. So, the 732 possibility does not exist. The sum of two digit numbers AB and CD is a 3-digit number 1CE. AB plus CD 1CE. Interesting. CD and then CE. One possibility is A is 0. But that is not the case, because if A were 0, this won't be a 2-digit number. So, A is not 0. Right? Very interesting. So, A is not 0. Right? But this is C, this is C. So, if A were not 0, then with a carryover, this should happen. So, B plus D should result in a carryover. 1 plus A plus C should retain C, or 1 plus A should become 10 plus C, C remains intact, and then something goes. Right? So this number A should be such that 1 plus A becomes 10, or A is equal to 9. 9B plus CD gives 1 CE, with the caveat that B plus D should be more than 10. If B plus D were 3 and 4, 3, 4, 7, 9 plus C can never be C. 3 and 8, 3 plus 8 is 11, 1 carried over, 1 plus 9 is 10, whatever this is, it will get reflected there. Yeah, that can work. And what do we need to find, and what is the value of A? A has to be 9, done through. 32 power 5 plus 2 power 27 is divisible by 32 is 2 power 5. 2 power 5 whole power 5 plus 2 power 27. 2 power 25 plus 2 power 27. This is 2 power 25 to 1 plus 2 square. 2 power 25 into 5. 2 square is 4. So, this number is 2 power 25 into 5. This is a multiple of 2, 4, 8, 16, everything. It's a multiple of 5. Is it a multiple of 3? No. 7? No. 11? No. 10? Yes. 2 into 5, 10. 421 and 427, which when divided by the same number, leave the same remainder 1. 421 divided by n, remainder is 1. 427 divided by n, remainder is 1. Nice. How many numbers can be used as a divisor in order to get the same remainder? So, if we divide 421 by n, remainder is 1, or n is a factor of 420. If you do n tables, 420 sits on it. 420 goes off completely, 1 remains. N is a factor of 420 and 426. N is a factor of A, n is a factor of B, n will be a factor of B minus A, or n is a factor of 6. In n tables 420 sits, in n tables 426 sits, right? Or n is a factor of 6. What are the factors of 6? 1, 2, 3 and 6. N cannot be 1, remainder is 1. N can take values 2, 3 and 6. HCF of 420 and 426 is 6. So, how many numbers can be used as a divisor in order to get the same remainder 1? 3 different numbers, 2, 3 and 6. Two persons P and Q enter into a business. P puts 14,000 more than Q and has invested for 8 months, and Q has invested for 10 months. So, P has invested, Q has invested some X, P has invested X plus 14,000. P has invested for 8 months, Q has invested for 10 months. If P share is 400 more than Q share out of a profit of 2,000, 400 more than Q share. So, profit, fine. P's profit, Q's profit. This is Y plus 400. Total profit is 2,000. 2Y plus 400 is 2,000. 2Y is 1600. Y is 800. So, this is 800. This is 1200. Right, this is a ratio in which they share profits. P gets 12,200, Q gets 800. Ratio is 3:2. They should get profits in the ratio of their investments, but not just the amounts. Should also keep in mind for the time period. And so, this is the rupee, this is the number of months, rupee into months. They should get returns in that ratio, or x plus 14,000 into 8 by x into 10 is 3 by 2. How did we get 3 by 2? 1200 by 800, 12 by 8, 3 by 2. Solve, cross multiply, simplify, we are through. Let's do this. This is 4, this is 5. Multiply this, 15x equals 4 into 2, 8x plus 8 into 14,000. 7x equals 8 into 14,000. X is 16,000. So Q has invested 16,000, P has invested 30,000. What is the capital contributed by P? 30. The total cost of 4 oranges, 6 mangoes and 8 apples is equal to twice the cost of 1 orange, 2 mangoes and 5 apples. Right? So 4 orange plus 6 mangoes plus 8 apples equals twice the cost, or is equal to 2 oranges plus 4 mangoes plus 10 apples. Multiplying this by 2. Bring suitably to this side. So this is 2 oranges plus 2 mangoes equal to 2 apples. Cost of 1 orange plus 1 mango equal to cost of 1 apple. That's what we know. 1 orange plus 1 mango's cost equal to 1 apple's cost. Which are the following statements? Cost of 3 oranges, 5 mangoes and 9 apples is equal to 4 oranges, 6 mangoes and 8 apples. 3 oranges plus 5 mangoes plus 9 apples should be equal to 4 oranges plus 6 mangoes plus 8 apples. Yes, this has to be true. If you bring this side, if you bring this side, we'll have 1 orange plus 1 mango equal to 1 apple. Yes, this is true. This is true. Second one, cost of 1 orange and 1 mango is equal to cost of 1 apple. Yes, this is also true. That's what we've got. Super question, just rejigging equations, getting the answers. Both are true. Let P and Q be positive integers satisfying P less than Q and P plus Q equal to K. What is the smallest value of K that does not determine P and Q uniquely? Smallest value of P and Q are 1 and 2. P is 1, Q is 2, K would be 3. Now we're doing the other way around. If K were 3, then can we uniquely determine P and Q? Yes, if K is 3, P has to be 1, Q has to be 2. Now, what are we thinking? So, if we take K to 4, P plus Q is 4, P is less than Q, both are positive integers. 1 plus 3 is 4, 2 plus 2 is 4, it cannot be 2 plus 2, this is 1, this is 3. So, if K were 3, we know for sure P is 1, Q is 2. If K were 4, we know for sure P is 1, Q is 3. Done. Now, put K as 5. Could be 1 plus 4, 2 plus 3. Both are 5. 1 is less than 4, 2 is less than 3. If K were 5, we cannot determine P and Q uniquely. So, smallest value of K that does not determine Q and P and Q uniquely is 5. Beautiful question because the way it is worded. If K is 3, we can say it is 1 and 2. If K is 4, we can say it is 1 and 3. K is 5, it could be 1, 4, it could be 2, 3. Cannot be determined uniquely, 5 is our answer. What are the least number of cuts required to cut a cube into 64 identical pieces? 64 identical pieces. It's a cube. 4 cube is 64. Suppose we have a cube quite beautifully like this. Okay. If you cut this 4 slices, 4 slices, 4 slices, 4 pieces, 4 pieces, 4 pieces, I'll have 64. and I know that. So what am I doing? I'm doing a mechanism to say, hey, there, let's break this into 4 pieces or equal pieces. And nice. So we got 4 times like this, 4 times like this, right? So on this, we further, so let's extrapolate this. This will also go like this. Right? 4 cuts like this, 4 pieces like this. That means 3 cuts. 1, 2, 3, 1, 2, 3. On top of that, we'll have to cut 1, 2, 3 like this. So let's put that also into the picture. Let's choose a different color. Let's do green. So imagine a cube. 1, 2, 3, 1, 2, 3, 1, 2, 3. Right? East west axis, north south axis, like this, and horizontal axis. 3, 3, 3, 9 cuts. We'll make 4, 4, 4 different types of pieces, 64 totally. So what is the least possible number of cuts? 9 cuts. In some code, P, Q, R, S, T represent numbers 4, 5, 10, 12, and 15. It is known that each letter represents, it is not known which letter represents which number. Q minus S equal to 2S. So Q is equal to 3S. One number should be thrice of another. So Q and S could be 4 and 12 or 5 and 15. Nice. 2 possibilities for Q and S. T equal to R plus S plus 3. T is equal to R plus S plus 3. Straight away we can sense that T should be high. R and S should be small. R and S smallest possible values are 4 and 5. 4 plus 5 plus 3 is 12. So T can be 12. And so that's a possibility. 4 plus 5 plus 3 makes us 12. That's a possibility. 4 plus 10 is the next smallest combo. 4 plus 10 plus 3 is 17. That's not available. I don't have to worry about anything else. This is not a possibility, this is the only possibility. R and S being the smallest possible values, I get one value of T. Next up is 4 plus 10, 14 plus 3, 17. That doesn't exist. Every other combo of 2 letters added plus 3 will be more than 17. I don't have to worry about it. This is the only solution. So T is equal to 12, R is equal to 4, S equal to 5. Only possibility. In that case, what will Q be? Q will be 15. R, S, Q, T are, we have found them 4, 5, 15, 12. Remaining letter is P. P should be 10. So not one combo, it is the only combo. What is the value of P plus R minus T? P plus R minus T is 10 plus 4 minus 12, 14 minus 12, 2. In a certain code, ABCD is 24, EFGH is 1680. 24, 1680. 1680 is 168 into 10 is 24 into 7 into 10. 4 into 6 into 7 into 10. I'm going to rejig this. I can say this is 4 into 6 into 7 into 5 into 2. Or it is 5 into 6 into 7 into 8. 2 into 4 is 8. ABCD is 24. 24 is 1 into 2 into 3 into 4. EFGH is 1680, 5, 6, 7, 8. What is IJKL? 9 into 10 into 11 into 12. 12 into 11 is 132. 132 into 9 and then a 0 at the end. 18, 8, 127, 28, 8. 11880. Thank you for watching. Check out the course details here.